Hi everyone, welcome to week 12. I'm so sorry for the delay in posting this screencast. We've been tied up, as you may know, in a 7-year cycle of a national accreditation review. We've had 3 days of hosting national reviewers from a variety of places around the United States and several state reviewers as well, looking at all of our programs in detail in the College of Education. We've had roundtable presentations and poster sessions, small group and large group interviews. Many of our candidates have participated in the process, and I'm happy to report that there's been an excellent outcome. So our programs remain able to do what we've been doing for years to come. So thank you for your patience. I want to give you some information about activities you are or will be engaged in this week. You should be reading the rather complicated chapter on experimental research in your text, and also read the article by Zinn at the end of that chapter on comparing two different word problem-solving strategies by Zinn. It represents a true experiment and is a good example of some of the concepts presented in chapter 10. The PowerPoint that I've posted will be very helpful to you. You might want to print it as a note-taking guide and fill it in as you go through the chapter, because if you are new to experimental notation and some of the concepts about true experimental research, as well as pre-experimental and quasi-experimental designs and keeping the design straight, it will be very helpful to you. I wanted to alert you to the fact that chapter 21 is a chapter that provides an overview of the paper you're writing in detail, preparing a research report. And if you don't have time to look at it this week, that's fine, but I want you to know it's there as a resource to you as you prepare your final paper for the class. And in a minute, I'll get to the writing workshop information. Right now, I wanted to spend a little time on your homework assignment and give you some information about that. So you are going to, as an applied example of your learning about chapter 10, actually, I'm going to start by highlighting some of the slides in the experimental research PowerPoint that I posted for you. So to remind you that experimental research represents the only type of research where you can test hypotheses to establish cause and effect relations. And the researcher, it has an active independent variable with two or more levels. So that means that the researcher actually manipulates the independent variable and controls other relevant variables. You'll learn a lot about extraneous variables and which experimental designs control for which extraneous variables that could threaten or contribute to the effect of the independent variable and threaten the claim that it was the treatment that caused the change rather than history or maturation or one of the other potential extraneous variables. So the experimental process is similar to other types of research. The researcher selects and defines a problem, selects participants and measuring instruments, prepares a plan, executes procedures, analyzes the data, writes up formulates conclusions, writes up results, and discusses the results in light of the literature. There are many challenges to conducting true experiments in educational settings. One of the most common problems is a lack of sufficient exposure to treatments. That is, the treatment is too short. I have a doctoral student right now who's conducting a study of the impact of a particular read aloud strategy with preschool students at a Head Start program. And she only has, because of the Head Start schedule and the spring break schedule, it worked out that she actually only has 5 weeks of intervention for this read aloud strategy. And it ends up being, so 5 times 2 is 10, times 5 is 50 sessions, which may or may not be long enough to show an effect. So it's very important to think about the length of time of the intervention, both when you're reading literature or designing your own study. Another challenge is failure to make treatments significantly different from one another. For example, an experimental instructional program in math might not be different enough from the comparison math instructional program for the control group to show a real difference. And so the study by Zinn is interesting in that one of the strategies, the experimental strategy, is a schematic to teach students to solve word problems as opposed to a more traditional word problem solving strategy. So think about that as you read that and see what you think for that particular study. A couple other slides I want to review with you before I show you my example of that homework assignment. One very important characteristic of research is to attribute the change on the dependent variable to the result of the treatment variable or the independent variable. And as you know, there are many possible competing or rival explanations for the effect of if there's a change shown on the dependent variable. And so experimental designs are designed to control for those extraneous variables. It is definitely challenging to control all the relevant extraneous variables, and there's a great table in your book in chapter 10 that shows the different kinds of designs and which extraneous variables they control for by the nature of the design. It's actually figure 10.2 on page 268 if you have the 10th edition. It's the sources of invalidity for true experimental designs and quasi-experimental designs. I wanted to also highlight the difference between validity and reliability in experimental designs as opposed to with regard to tests and measurements that we read about earlier. So internal validity refers to the degree to which observed differences in the dependent variable are a direct result of the manipulation of the independent variable and not some extraneous variable. That's how validity is defined in experimental research. And it's concerned with rival explanations for an effect. External validity, by comparison, is also referred to as ecological validity, and that refers to the degree to which the results from a study are generalizable to other groups. And interestingly, when researchers increase the internal validity of a study, they decrease their external validity. And that's because to increase the internal validity, they have to better control the treatment variable and extraneous variables, and so a classroom becomes more laboratory-like. And if it's more laboratory-like and pristine and, it's less natural, and so then therefore external validity is compromised because it's less like what a real classroom is like. There are a variety of threats to internal validity. These include history, maturation, testing, instrumentation, statistical regression toward the mean. This refers to, in a pretest, there might be some outlier scores. If you retest that same group of test takers, it's likely that they would move closer to the mean. If they were very high, move down a little bit. If they were very low, move up a little bit. There might be differential selection of participants, mortality, which refers to participants dropping out of a subject dropping out of a study before the study ends. and different extraneous variables can interact with one another. There can be selection, maturation, and interactive effects. And you'll read about each of these so that you have a sense what each of them are, and again, which designs control for which extraneous variables. So continuing our discussion of some of the features of experimental designs, it's important to note and to highlight that randomization is the best mechanism to control for extraneous variables. And this is the feature that distinguishes experimental designs over designs that aren't true experiments. Randomization should be used whenever possible. If groups can't be randomly formed, variables should be held constant when at all possible. And the next best thing to random selection, and random selection, if you remember from the sampling chapter, says that every participant in a sample has an equal opportunity to be chosen for the treatment or be part of a control group. If that's not possible, the next best thing is random assignment of treatments to intact groups. And that distinguishes the difference between quasi-experimental and experimental designs. There are two major classes of experimental designs, single variable and factorial designs. We'll focus mainly on single variable designs. There are pre-experimental designs. Often these are used as pilot studies, getting ready for a true experiment. And they do not adequately control for a variety of extraneous variables, so should be avoided for a real, a large research project. And true experimental designs offer the best degree of control. They're always preferred. They're generally considered the gold standard in quantitative research. Quasi-experimental designs, as I said, the difference is you're not able to do random assignment or random selection of individual participants in each group, but they are distinguished by random assignment of treatment to intact groups. The next section of your chapter 10, beginning on page 265, describes with experimental notation some pre-experimental designs, then goes to true experimental designs, and ends with quasi-experimental designs. And this is directly applicable to your homework assignment, so let me talk you through this a little bit. Make sure you understand what these symbols stand for, and there's no R, so there's no random selection and assignment of participants to this group. This is a one group, pre-test, post-test design. This is the intervention. This is the pretest, this is the post-test, very simply. There are a lot of potentially confounding variables that can contaminate the results of this design. Statistical regression is not controlled. It doesn't control for history, testing, instrumentation, or maturation. Another pre-experimental design is the static group comparison design. This involves, it has a comparison, so there are two groups, and they're not randomly formed. There's no R notation, which indicates random selection of participants and assignment to different treatment groups. So there's a treatment and there's no treatment. So some sort of math, special schema, problem solving perhaps, versus a traditional story problem technique, and a post-test. So no pre-test. And that's basically what those notations mean. Let me show you one more. Let's get into some of the pre-test, post-test control group, or the true experimental designs. The pre-test, post-test control group design. This, because it says control group, involves two groups. It can be more than 2 groups, but in this particular design it's 2. Both groups are administered a pretest. Each group receives a different treatment and both groups are post-tested, and they may include additional groups. So here's one showing 3 groups. Random selection indicates a true experiment. Pretest, some sort of intervention, post-test. Random selection, pretest, this is group 2. Maybe they have traditional instruction, maybe this is some instructional, maybe this is classroom innovation, maybe this is online. So 3 different kinds of instruction, 3 pre-tests, 3 post-tests. This is a powerful design. The only potential weakness that is not controlled is a possible interaction between the pre-test and the post-test. There's the potential for learning on the pre-test to impact the outcome rather than be solely attributable to the different interventions. I'll show you one more here before I show you the homework example. So this is a post-test only control group design. Again, more than 1 group because of the notion of a comparison or a control group. There's random selection, which again indicates a true experimental design. Sorry. And there's no pretest, so no 0 noted here. 1 intervention and traditional or no intervention for the second group, the control group, and a post-test. This controls for all extraneous variables. Oh, sorry. It controls for all extraneous variables except mortality. If you look at that table on page, or the figure on page 268, and that's because, remember, mortality is participants dropping out. We don't know that if they drop out because there's no pretest to compare with a post-test. So that's the only extraneous variable that might confound the results. Let's go through your homework, an example for your homework. So you are to work through one complete example for experimental designs, and you might use peer tutoring, same age versus cross-age tutoring to draw these different designs, or you can make up your own variables to work through each of these designs. So let me give you an example. Here's my hypothetical research question. Is there a difference in SAT scores between test takers who took a preparation course and those who did not, just prepared on their own? And so first I'm going to show that with experimental notation with a couple of the pre-experimental designs. Again, I don't want you to use those designs for your research proposal, but I want you to be aware that these are used sometimes for pilot studies, getting ready for a true experiment. The first is a 1-group pre-test, post-test design. Here it's noted. Hope you can read my writing. So 1 group, so this is the 1 group. A pre-test might be a practice ACT test, or SAT, I'm sorry, and then the training. They participated in a week-long or online or some sort of professional training about taking the SAT, and then they take the test. The independent variable is the SAT training. The dependent variable is achievement on the SAT test. So moving to, and by the way, the independent variable has 2 levels. They took the training or they didn't. They prepared on their own. So let's look at another example. This is also a pre-experimental design. Number 2 is a static group comparison design. So because there's a comparison group, there's 2 groups. 1 took the professional training and then took the SAT. 1 prepared on their own or didn't prepare, and then they took the SAT. You can already think of some confounding or rival explanations for their scores on the SAT rather than just training or no training. For example, who signs up for a training? Maybe they're very bright already and they know the training would help them score even better. They're trying to get into an elite university. So their intelligence and prior experience and prior knowledge coupled with the training leads to an elevated score, not just the training. Or maybe they took the SAT previously and are deciding to take the training because they did poorly the first time. So some of that practice effect of the first taking of the test influences then their second score in addition to the training. Maybe in this group you have very bright people who feel they don't need the training and they do well, so there's no significant difference between this group. So if these groups were formed randomly, you would have a cross-section of folks in both groups, and that's how randomization really helps you infer that the training, if there is a difference in the score, then it's due to the training and not some other pre-existing or extraneous variable. Let's move on to experimental designs. The first is the pretest post-test control group design. Again, there are a couple groups, there could be more than two. There's random selection and assignment to groups, whether or not they take the professional training or prepare on their own. So this is a much more powerful design in that it controls for many more extraneous variables than this design or this one. They take some sort of practice test, the SAT practice test. They participate in the intervention or prepare on their own, and then there's an examination and a comparison statistically of whether or not the scores are different. And the hypothesis would be that taking the training leads to a better performance on the SAT. Moving on, remember that the only confounding variable with the pretest post-test control group design is the testing effect, the effect of the pretest influencing the performance. So some learning happening as a result of the pretest influencing the post-test or the SAT score, and not just the training. A design that controls for that pretest effect is the next design, which is the post-test only control group design. So notice that in experimental designs, the comparison group is called in experimental designs, the comparison group is called the control group. That's also true in quasi-experimental designs. But because pre-experimental designs lack experimental control, it's called a comparison group. Okay, the post-test only control group design, there's no pretest, so you eliminate learning from a pretest. And remember this, so there's random selection and assignment to one of two groups, professional training, prepare on your own, and a comparison of achievement on the SAT. The only extraneous variable not controlled for by this design is mortality, whether or not some participants drop out, which influences the power of the randomization. So you begin to see with these examples, I hope, that it's not always best necessarily to use a pretest post-test control group design. Maybe sometimes if you're worried about the testing effect of the pretest confounding your results, it might be better to choose the post-test only control group design. So the design selection is really affected by your design questions, your research questions. The next design is really rather complex and really interesting. It's the Solomon 4 group design. So there are 4 groups. You have to have a very large sample to be able to do this well, and for it to meet the assumptions of statistical tests for analysis. 2 are pre-tested and 2 aren't. So really it's a combination of the pretest, post-test control group design and the post-test only control group design. And that way you control for all extraneous variables. So read about that design. You can test for a pretest effect by comparing with the post-test only group, and you control for mortality by comparing with this design, within this complex design. Let's look now at quasi-experimental designs. Again, you don't see the R, so these are often done in educational research because you frequently have intact groups, and the best that you can do to establish some control is do random assignment of treatment to intact groups. So again, I said here no random assignment to groups, random selection. It could be random assignment of treatment to intact groups. So here's the group that takes the professional training. Here's the group that prepares on their own. Both groups are pre-tested on a practice test. We might assume that, this is one high school class and another high school class. These folks were offered the training, and that it was randomly decided which group got the training and which group didn't. And this is another class that didn't, and then the scores are compared. It's more powerful, much more powerful, and you can see which extraneous variables it's controlling by looking at that table. It's more powerful than those pre-experimental designs, but not as powerful as the true experimental designs. And then I did not draw, I'll let you play with on your worksheet either a counterbalance design or a multiple time series design. And finally, the last question on your paper is, which design would you recommend for your hypothetical research question and why? So for our question, our example here, if the SAT practice test contributes significantly to learning, we would choose number 4, the post-test only control group design. And here's the design. And the reason is it's more powerful than the quasi-experimental designs at controlling extraneous variables. It's less complex and requires fewer participants than the Solomon 4. But actually, if we had hundreds of participants, the Solomon 4 would be the best design choice for our research question. So I hope this is helpful to you to walk through this example. And again, for your paper, you will pick your own hypothetical research question, identify the independent and dependent variables, and use those same variables throughout to denote the different designs, and then answer the question at the end. You can use same age versus cross age tutoring. For those of you who aren't familiar with that, this would be classroom peers tutoring one another, or students of the same age and grade tutoring in a particular class, as opposed to kids who are from high school tutoring in an elementary school classroom, something like that. And work through, using experimental notation, each of the designs. Finally, I want to talk a little bit about the writing workshop. Robert has set you up in a writing group. Your peers' writing should already be posted in the workshop, and you have a choice of critiquing your peers' writing in a variety of ways. And let me just say a little bit about the critique. Robert posted for you the rubric, and so that you're thinking deeply about your peers' writing and offer some constructive suggestions. We definitely want you to let your writing peers know when you think they've done a great job on a particular section, that it makes sense to you. One of the nice things about doing this is you are in groups that are fairly heterogeneous in terms of the topics selected. If something isn't clear to you, it's also helpful to ask your peer to provide a bit more context or explanation of some of the concepts they're trying to explain. And sometimes when each of us is writing a paper and we've read a lot about that topic area, we forget that an uninformed audience who may be less knowledgeable about the topic might not understand a particular concept. And so that's one way you could offer a suggestion. You can also talk about the quality of the writing, maybe a suggestion to add a transition sentence between paragraphs if something seems awkward to you. Hopefully, you'll get into some substantive critique with each other and a discussion. And I encourage you to use VoiceThread. That's you could post the paper and comment using VoiceThread, which is a webware free software program. You could use a Google Hangout, arrange with your group to meet on Google and discuss your writing. I encourage you to do that if that's a possibility. Or you could use track changes. And I'm excited to see the forum and the setup that Robert has posted because I think it also will help facilitate some feedback to one another. So that's the end of my comments here, and we look forward to entering the writing workshop with you. Take care.